There exists a market that moves trillions of dollars annually, yet remains completely invisible to most people. As you read these words, millions of screws are being manufactured, transported, and installed across every continent. This seemingly insignificant component literally sustains the entire infrastructure of modern civilization. From skyscrapers that defy gravity to smartphones that fit in your pocket, everything depends on these small threaded metal cylinders. The global metal fastener industry represents one of the most lucrative and stable markets in the world economy. Unlike volatile sectors such as technology or fashion, demand for screws grows consistently, decade after decade. Every building constructed, every vehicle manufactured, every bridge erected consumes astronomical quantities of these components. The scale of this demand transforms a product worth pennies into a trillion-dollar business. What makes this market particularly fascinating is its absolute economic resilience. While technology companies emerge and disappear, while fads come and go, the screw industry remains unshakable. No recession can eliminate the need to build, repair, and maintain structures. No technological innovation has managed to replace the mechanical efficiency of a well-designed screw. The numbers reveal a surprising reality. Humanity produces more than 500 billion screws annually. If you stacked all the screws manufactured in a single year, the resulting tower would reach the moon and return multiple times. This colossal volume transforms cheap raw material into revenue streams that feed entire economies. Countries specialized in this production accumulate silent wealth that rivals glamorous industries. The true genius of this market lies in its strategic invisibility. While everyone pays attention to final products, cars, airplanes, computers, nobody questions the thousands of screws that make these products possible. This invisibility creates profit margins protected from the volatility that plagues more visible markets. The screw is the most lucrative secret that the global economy hides in plain sight. When you analyze the economic structure of a screw, you discover fascinating financial alchemy. 1 kilogram of steel wire costs a few dollars in the international market. That same kilogram, transformed into specialized screws, can be worth 50 times more. This multiplication of value does not happen by magic, but through industrial processes that convert common metal into components of critical precision. The profit margin varies dramatically according to the specialization of the screw. Common screws for civil construction generate modest margins, but astronomical volumes. Aerospace screws, produced with special alloys and microscopic tolerances, can cost hundreds of dollars each. Between these extremes exists an infinite spectrum of lucrative niches that feed thousands of specialized companies. The business model is extraordinarily scalable. A modern factory operates 24 hours a day, 7 days a week, producing millions of units with minimal human supervision. Fixed costs are diluted over immense volumes, while automation eliminates variable expenses. This combination creates operational efficiency that few sectors can replicate. The geographical distribution of production reveals sophisticated economic strategies. Countries with low energy costs dominate the production of basic high-volume screws. Nations with advanced metallurgical expertise concentrate on specialized high-value fasteners. This international division of labor optimizes profits globally, creating supply chains that cross oceans to save fractions of a cent per unit. The true economic power emerges when you multiply small margins by colossal volumes. A manufacturer that profits 5 cents per screw, producing 1 billion units annually, generates 50 million in net profit. Companies that dominate multiple segments of this market accumulate fortunes that remain out of the spotlight, building silent industrial empires that span generations. The modern economy has developed an absolute dependence on screws that few completely understand. Every critical industrial sector, automotive, aerospace, civil construction, electronics, energy, depends on constant and reliable supply of these components. This universal dependence confers on screw manufacturers a market power disproportionate to public perception about the industry. When an automotive manufacturer designs a new vehicle, it specifies thousands of different screws with precise tolerances. Changing suppliers requires expensive and prolonged recertification of each component. This technical inertia creates commercial relationships that last decades, generating predictable revenue streams that investors love. The resulting financial stability allows long-term planning impossible in more volatile sectors. The criticality of screws in safety applications amplifies their economic value. A defective screw in an airplane engine can cause catastrophe. This reality transforms quality control into monetizable competitive advantage. Manufacturers with impeccable reputation charge substantial premiums, knowing that customers will never risk insignificant savings on critical components. Industrial consolidation has concentrated market power in a few global corporations. These giants control patents, proprietary processes, and customer relationships that create practically insurmountable barriers to entry. New competitors face decades of investment in reputation and certifications before competing effectively. This natural protection against disruption preserves lucrative margins indefinitely. The network effect amplifies the dominance of market leaders. Engineers design products using standardized screws from established suppliers because specifications are readily available and supply is guaranteed. This preference for existing standards perpetuates the dominance of incumbent manufacturers, creating virtuous cycles of growth that, compounded over decades, build immense corporate fortunes. While the public imagines screws as technologically stagnant products, reality reveals constant innovation that generates lucrative, competitive advantages. New thread designs increase fastening strength, allowing lighter and more efficient structures. Advanced coatings prolong service life in corrosive environments, reducing maintenance costs. Each incremental improvement captures economic value through patents and proprietary expertise. Screw metallurgy has evolved dramatically in recent decades. Special alloys withstand extreme temperatures in rocket engines. Precise heat treatments optimize hardness and ductility simultaneously. These material innovations enable previously impossible applications, opening entirely new markets. Companies that master these technologies charge substantial premiums for unique capabilities. Digitalization has transformed manufacturing processes without visibly altering the final product. Sensors monitor each production stage, eliminating defects before they occur. Artificial intelligence optimizes machine parameters in real time, maximizing energy efficiency. This invisible modernization dramatically reduces operational costs, expanding margins without increasing prices. Mass customization has emerged as a lucrative strategy. Flexible production systems manufacture small batches of specialized screws economically. This capability serves market niches willing to pay premiums for exact solutions. The long tail of specialized products generates margins superior to high-volume commoditized products. Sustainability has become a valuable competitive differentiator. Screws manufactured with recycled steel and energy-efficient processes attract environmentally conscious customers. Sustainability certifications justify premium prices in developed markets. This trend transforms environmental responsibility into financial advantage, aligning profit with positive impact. Screw logistics reveals surprising complexity that generates economic opportunities at each link in the chain. Manufacturers need to coordinate steel supply and distribution to thousands of customers globally. Companies that master this logistical orchestration capture margins through superior operational efficiency. Maritime transport of screws moves immense volumes continuously. Containers cross oceans loaded with tons of fasteners destined for factories on every continent. This constant movement feeds an entire specialized logistics industry. Freight forwarders, warehouses, distributors. Each intermediary captures value by facilitating product flow. Inventory management represents simultaneous challenge and opportunity. Industrial customers demand immediate availability of thousands of different types of screws. Distributors who maintain comprehensive inventories charge premiums for convenience. This financial intermediation transforms working capital into predictable revenue streams. Purchase consolidation generates significant economies of scale. Large construction companies and manufacturers negotiate supply contracts that guarantee favorable prices in exchange for guaranteed volumes. Manufacturers value this predictability, offering discounts that still preserve healthy margins. Both sides win through mutually beneficial long-term relationships. Traceability has become a regulatory requirement in critical industries. Each screw installed in an airplane has complete history from raw material to final installation. Systems that manage this traceability add substantial value, transforming regulatory compliance into competitive differentiator. Information about the product becomes as valuable as the physical product. The screw industry demonstrates remarkable resilience through economic cycles that devastate less essential sectors. During recessions, new construction slows, but maintenance and repair continue. This defensive demand stabilizes revenues when other markets collapse. Sophisticated investors recognize this stability, valuing fastener companies as safe havens in economic storms. Diversification of end markets protects manufacturers from sectoral shocks. When the automotive industry faces crisis, civil construction may be growing. When manufacturing slows, renewable energy may be accelerating. Companies that serve multiple sectors smooth volatility, generating consistent returns that compounded over decades build substantial wealth. Raw material cost inflation affects the entire industry simultaneously, allowing coordinated price pass-throughs. When steel becomes more expensive, all manufacturers increase prices proportionally. Customers accept these increases because alternatives do not exist. This dynamic preserves percentage margins even when absolute costs fluctuate. Globalization has created lucrative geographical arbitrage. Manufacturers establish operations where costs are minimal and export globally. Differences in labor, cost, energy, and regulation create profit opportunities through geographical optimization. Companies that master this global arbitrage accumulate cost advantages that local competitors cannot match. Progressive automation continuously reduces operational costs. Each generation of equipment produces more screws with less energy and human supervision. Companies that invest aggressively in modernization gain permanent cost advantages. This technological race favors market leaders with capital to invest, consolidating dominance over time. Patents protect innovations in screw design, creating lucrative temporary monopolies. A new thread design that increases fastening strength by 20% can generate royalties for decades. Companies that accumulate patent portfolios build defensive moats that protect premium margins. Intellectual property transforms engineering into valuable financial assets. Tacit knowledge represents a more powerful barrier to entry than patents. Heat treatment processes, coating formulations, machine adjustments, expertise accumulated over decades cannot be easily copied. This knowledge advantage allows incumbents to maintain technical leadership even after patents expire. Regulatory certifications create substantial barriers to entry in high-value markets. Qualifying screws for aerospace use requires years of testing and costly documentation. Established manufacturers amortize these costs decades ago. New entrants face immense investments before generating revenue, discouraging competition. Long-term relationships with critical customers function as implicit contracts. Engineers specify screws from reliable suppliers out of habit and accumulated trust. Changing suppliers requires justification and approval at multiple organizational levels. This institutional inertia protects existing revenues against competition based solely on price. The minimum efficient scale of production eliminates small competitors. Modern equipment costs millions and is only economically justified by producing immense volumes. This reality concentrates production in a few large facilities, each serving continental markets. Natural economies of scale create stable oligopolies that share markets profitably. Accelerated urbanization in emerging economies drives screw demand exponentially. Every city built, every factory installed, every vehicle sold multiplies fastener consumption. Companies that establish presence early in these markets capture growth that doubles revenues every few years. Geographical expansion transforms regional companies into global giants. The transfer of manufacturing to low-cost countries redistributes production globally. Factories close in developed nations and reopen where labor is abundant and cheap. This industrial migration creates opportunities for agile companies that establish operations in optimized locations. Global cost arbitrage generates margins that domestic competitors cannot match. The growing middle class in emerging markets raises quality standards. consumers demand more durable and safer products, requiring superior screws. This evolution of preferences allows premium quality manufacturers to expand markets beyond developed economies. Global quality upgrading expands addressable markets for higher-margin products. Massive infrastructure under development consumes astronomical quantities of screws. High-speed railways, intercontinental bridges, expanded electrical grids. Each mega-project represents immense supply contracts. Companies that win these contracts guarantee revenues for years, financing additional expansion. Global infrastructure under construction feeds industry growth for decades. Locating production close to customers reduces logistics costs and delivery times. Manufacturers establish regional facilities to serve local markets efficiently. This distributed production strategy captures proximity advantages while maintaining economies of scale through process standardization. Intelligent globalization optimizes profits through locally coordinated global presence. Steel recycling makes screws intrinsically sustainable products. Demolished structures release tons of fasteners that return to steel mills. This closed loop reduces dependence on mining and decreases environmental footprint. Companies that integrate recycling into business models capture value from material flows that others discard. The durability of well-designed screws prolongs the service life of final products. Fasteners that resist corrosion and fatigue allow structures to operate decades beyond original expectations. This longevity reduces resource consumption over time, aligning economic performance with environmental sustainability. Products that last longer cost less over the life cycle. Ecological coatings replace traditional toxic treatments. Water-based processes eliminate hazardous solvents without sacrificing performance. This green innovation meets growing environmental regulations while reducing compliance costs. Sustainability becomes competitive advantage in strictly regulated markets. Energy efficiency in production reduces operational costs and emissions simultaneously. Electric furnaces powered by renewable energy manufacture screws with minimal carbon footprint. Corporate customers value sustainable suppliers and supply chains, paying premiums for certified products. Decarbonization transforms into lucrative market differentiator. The circular economy creates innovative business models. Companies offer recovery and reconditioning services for specialized screws. Expensive aerospace fasteners justify inspection and recertification processes that extend service life. This transition from product to service generates recurring revenues and deepens customer relationships. Mergers and acquisitions have concentrated the screw industry into a few multinational corporations. These giants control dozens of brands, hundreds of facilities, and relationships with practically all significant industrial customers. This consolidation generates pricing power and operational efficiencies that dramatically amplify profits. Vertical integration captures margins along the value chain. Companies acquire steel suppliers and finished product distributors, controlling input costs and market access. This strategy eliminates intermediaries and captures value that previously leaked to partners. Verticalization transforms manufacturing companies into integrated industrial ecosystems. The acquisition of competitors eliminates destructive price wars. When market leaders buy rivals, they consolidate productive capacity and rationalize operations. Redundant factories close, excess capacity disappears, and price discipline returns to the market. This consolidation benefits shareholders through expanded margins and superior returns. Access to capital favors large companies that finance expansion through public markets. Listed corporations issue stocks and debt at costs that private competitors cannot match. This cheap capital finances acquisitions, modernization, and geographical expansion. The financial advantage of scale perpetuates the dominance of established leaders. Product diversification through acquisitions stabilizes revenues and expands addressable markets. Companies that manufactured only screws acquire producers of nuts, washers, and other fasteners. This portfolio expansion enables cross-selling and deeper customer relationships. Related diversification amplifies corporate value beyond the sum of the parts. Additive manufacturing simultaneously threatens and complements traditional production. Three-dimensional printing enables rapid prototyping of customized screws without expensive tooling. This capability accelerates product development and serves niches previously economically impossible. Companies that integrate additive and traditional technologies capture advantages of both. The Internet of Things transforms screws into intelligent sensors. Fasteners equipped with chips continuously monitor tension, temperature, and vibration. This data feeds predictive maintenance systems that prevent failures before they occur. The digitalization of physical products creates recurring revenue streams through data-based services. Digital e-commerce platforms democratize access to specialized screws. Small customers purchase products previously available only through large distributors. This disintermediation captures distribution margins while expanding addressable markets. E-commerce transforms transactional relationships into valuable data platforms. Artificial intelligence optimizes screw design through computational simulation. Algorithms test thousands of variations virtually, identifying optimal configurations instantly. This development acceleration reduces time to market and engineering costs. AI transforms into a competitive tool that amplifies human capabilities. Blockchain tracks screws through complex supply chains immutably. Each transaction is recorded permanently, creating unquestionable provenance histories. This transparency meets regulatory requirements and prevents counterfeiting. Distributed ledger technology adds layers of value through verifiable trust. The electrification of transportation multiplies demand for specialized screws. Electric vehicles contain more fasteners than traditional automobiles due to heavy batteries and complex electronics. This global energy transition creates growth opportunities that will sustain the industry for decades. Technological change dramatically amplifies existing markets. Commercial space exploration opens literally new frontiers. Reusable rockets, private orbital stations, and asteroid mining require screws that operate in vacuum and extreme temperatures. This nascent market values performance above cost, generating extraordinary margins for qualified manufacturers. Space represents the next frontier of industrial expansion. Nanotechnology promises screws with previously impossible properties. Nanostructured coatings completely eliminate friction and corrosion. Advanced materials combine the lightness of aluminum with the strength of titanium. These material innovations will create entirely new categories of premium products. Materials science will fuel product differentiation indefinitely. Mass customization through digital manufacturing will serve infinitely fragmented niches. Each customer will specify exact screws for unique applications economically. This long tail of customized products will generate margins superior to standardized products. Customization transforms commodities into valuable specialty products. The integration of sustainability and profitability will define future leaders. Companies that decarbonize production, close material loops, and eliminate waste will gain preference from customers and investors. This convergence of environmental responsibility and financial performance will create lasting competitive advantages. The future belongs to companies that profit by doing good for the planet.